All right. Hello, everyone. Thanks for taking the time to either join live or to watch this recording. I appreciate you. This is Poliventure Workshop Week 3. What I'll do is I'll give a brief overview of the workshop, and then we'll jump right to Week 3, which is about networks. All right. I'm already sharing my screen, so you should see here the PowerPoint presentation. Now, we have this workshop every Wednesday through the term from 8 to 8:30. Now, in week 1, I gave an overview of this workshop, and basically Poliventure is a new workshop series that explores how games relate to concepts in political science. And I'll be live streaming games such as Risk and Civilization and others. If you have suggestions, feel free to reach out to me, and I'm happy to cover those games. For week 3, what I'd like to do is introduce a new concept for us, and that is a concept of networks. So our learning objectives for this workshop are the following. First, by the end of this workshop, you'll be able to define network theory. Secondly, you'll be able to explain what a network is. And then lastly, you'll be able to apply network analysis to the game of Risk. Now, recall that in weeks 1 and 2, I introduced 4 concepts: communication, information, strategy, and moves. And for each of those, we looked at 2 facets or types of it. Like communication can be direct or indirect. Information can be complete or incomplete, and so on. What I'd like to do for this week is to add a 5th concept, and that is a concept of the network. And in this case, we can look at networks that are simple, and we can look at networks that are complex. Now, there's this a field of study called network theory, and it's the study of graphs as a representation of either symmetric relations or asymmetric relations between discrete objects. And in computer science and network science, network theory is a part of graph theory, which a network can be defined as a graph in which nodes and or edges have attributes, for example, names. Now, when it comes to network graph and elements, this is a visualization here on your left, which you'll see dots and lines. And the dot is what we call a vertex, and the line is what we call an edge. And then in the field of political science, we'll typically use the following language, which a dot is a node and a line is a connection. Now, here's an example of a simple versus a complex network. On the left-hand side, you see a simple network, which is 4 nodes that are each connected to 2 other nodes. But you'll note here that the node in the top left and the node in the bottom right are not connected to each other, and the same would go for the node in the bottom left and the node in the top right are not connected to each other. This would be an example of a simple network because we're seeing a few nodes and a few connections. Now, on the right-hand side, we have a complex network, and here we see about a dozen nodes and a range of connections and different branches in different directions. So if we just thought about networks as either simple or complex, just visually seeing it would give us that indication of whether that's the case. Simple is fewer nodes, fewer connections. Complex is more nodes, more connections. Now, what I'd like to do is unpack this a little bit more for us to kind of get a sense of how it could relate to games that we might be interested in playing or that we do play. So network theory is like the broad umbrella, but I think one that's more appealing to folks is social network analysis. And social network analysis, or S&A, is the process of investigating social structures through the use of networks and graph theory. It characterizes network structures in terms of nodes, and nodes can be individual actors, people, or things within a network, and they can be ties and edges or links, so relationships or interactions that connect them all. Now, examples of social structures include things like social media networks, how memes spread, information circulation, friendship and acquaintance networks, business networks, knowledge networks, difficult working relationships, social networks, collaboration graphs, kinship, disease, transmission, and sexual relationships. So social network analysis covers a whole range of different things. If there's a person or a thing that can be connected with each other, you can probably do social network analysis on it. Now, make a note that for many of those, for all those examples of networks, they're often visualized through what we call sociograms, in which nodes are represented as points and ties are represented as lines. These visualizations provide a means of qualitatively assessing networks by varying the visual representation of their nodes and edges to reflect attributes of interest. So you might be asking, okay, how does this apply to the game of Risk, right? Which is what we talked about in the prior weeks. Well, let's go ahead and apply this notion of network theory and of social network analysis to the game of Risk. Now recall that there's a board game of Risk, and this one picture that you see here is that you have the different continents with the different countries inside of them. And obviously this is a game of incomplete information, because unless you're connected to a particular country or adjacent to it, you won't see who owns it and how many troops are in it, right? So any country that has a little question mark, we don't know what's going on in there, but we get an overall sense of the map, right? And what's interesting is that we can unpack this map, and we can look at the underlying network that this map represents. And so with that, what I like to do here is show you on a slide. On the left-hand part, you'll see a table, and in both the header row, which is here on the top, and in the header column, which is here on the left-hand side, you'll see a list of countries, starting with Alaska, Northwest Territory, Greenland, Alberta, Ontario, Quebec, Western United States, Eastern United States, and Central America. And what you'll see in the cells is the number 1 or a blank space. So for example, if we look at the cell Alaska, the cell that intersects those row and column, it's blank, right? And the idea here is that a country isn't connected to itself. However, if we look at the node, the row Alaska, and then we look at Northwest Territory, we see that there is a connection. And you might be asking, well, how does that work? Well, let me go ahead and draw a picture here to demonstrate that. I'll turn on the draw function here. And what we see is that Alaska's here, and it's connected to the Northwest Territory. So then it's it's represented here in this table. If we're looking at Alaska, it's connected to the Northwest Territory. And if we're looking at Alaska in the column, it's connected to the Northwest Territory. So what we see on the right is the visualization of that connection. And on the left is the table or the numeric representation of those connections. Now, with that in mind, what I like to do is, zoom us out from just the North American continent and the countries there, and let's look at the entire map of Risk, and then see how that would be represented in a network graph. So here on the left is the picture, the screenshot from the game Risk, and on the right-hand side, you'll see the network graph. And you might be asking, okay, how do I see the correspondence between these two things? Well, I'll give an example. So here on the top right, and I'll use a different color to denote this, you see a diamond connection or network. This diamond connection is equivalent to Oceania, which includes these 4 countries, right? Eastern Australia, Western Australia, Java, and Indonesia. So on the left-hand side is this visually appealing representation of the network in the form of the Risk game. And on the right-hand side, what we see is just the underlying network that feeds this or is a part of this game. So now what we'll do is we'll look at this and unpack it a little bit further. So here's the network graph again, but now I've added the labels for these countries. And so, for example, that diamond that we showed in the top right, you'll see Eastern Australia, it's kind of small, but Eastern Australia, Western Australia, Indonesia, and New Guinea are all connected to each other. Now, there's things that we can do with network graphs, like just look at them and be like, oh, that's interesting. Like, for example, in order to get to New Guinea, Western Australia, or Eastern Australia, I need to go through Indonesia. Or, for example, if I want to get from Africa or Asia, I should probably go through North Africa to get to Brazil and then to South America. Now, what we can do to this network graph, among many things, is to add attributes to each of these nodes, in this case, countries, and then to work with those attributes to better identify and better visualize the network graph. So here's the network with the attribute of continent. And what we have here is each node, instead of now it just being a blue circle, it's a different shape and a different color. So for example, we'll see here on the left-hand side, this diamond shape, this diamond part of the network. And let me go ahead and highlight that, the pen. So you'll notice a couple of things. First, that the triangle, so we went from a circle to a triangle, and we went from the color blue to the color purple. So we used the fact that these 4 countries are on the Oceania continent. And then we said, we want to give them a different symbol, in this case, an upside down triangle, and we want to get them a different color, in this case, purple. And so we can see that for these other parts as well. For example, in this lower right region, we'll see the North American continent, and so on. So this is the risk board game represented in a network graph. Now, there's one concept of network theory and of social network analysis that I want to introduce you to, and then we'll get to our discussion. And that is this concept of centrality. So centrality is a helpful measure for identifying key players in a network. Now, depending on the specific measure of centrality used, there's three that I want to bring to your attention. The first one is degree centrality, and this is here on the bottom left. And this means a network is directly connected to many others. So in other words, if there's connections and you have a lot of connections, then your degree centrality is higher. If you have fewer connections, your degree centrality is lower. The second measure of centrality is what we call closeness centrality, and this means you're close to many others indirectly. So say you are connected to your family, which means that's a direct connection. So your closest centrality is low with your immediate family. But if you went from your immediate family to your extended aunts, uncles, cousins, and to their children and to their spouses and to their cousins and so on, your closeness centrality increases with those second, third, and fourth level connections, because they're indirect to you, right? Your direct is your mom, your dad, your siblings. And then as your indirect connections grow, your closeness centrality increases. The last measure of centrality is what we call betweenness centrality. And this is where some node serves as a key broker between many other nodes. Think about it this way. If you have a group of friends and one of your friends is like the go-to in coordinating with another group of friends, then that go-to friend is what we would have a high betweenness centrality, because there seemed to be a key broker between your group and another group. So what I like to do is demonstrate this visually, and then we'll go ahead and get to our discussion. Now, when it comes to centrality and degree centrality, recall that this means a network is directly connected to many others. So what you'll see here are the different nodes. And if the node is larger, the symbol itself, then that represents it has a high degree centrality. So let me see if I can zoom in here just a bit to give us some clarity. So if you take a look at this screen, what looks like the country that has, or the region that has, the largest degree centrality? Now you might say, okay, let me look at that diamond that you've been pointing at each time. And we see here that none of these nodes are very large, which suggests that they don't have a high degree centrality, right? That they're not connected to a lot of others. And that seems to make sense, right? Eastern Australia is small because it's only connected to two other countries, either New Guinea and Western Australia. Indonesia is a little bit bigger because it's connected to New Guinea, Western Australia, and in this case, Southeast Asia. Now, take a close look at this graph, and let me zoom out just a little bit. Which of these nodes looks the largest? Let me go ahead and get my pen for this. So you might be saying, all right, well, for example, the Middle East looks pretty big. Ontario looks pretty big. China seems to be near there. Maybe Central America. Right. And in this case, the Middle East is the largest because it has at least 1, 2, 3, 4, 5, 6, 7 connections, compared to Ontario, which seems to have 1, 2, 3, 4, 5, 6, compared to China, which seems to have 1, 2, 3, 4, 5, 6 as well. So in this case, China and Ontario have the same degree centrality in the risk board game, which means they have the same number of connections. And in this case, the Middle East has the most connections to other countries, which would mean it has the highest degree centrality. Now, you might be asking, okay, how does this relate to political science? Well, in political science, we're interested in who is connected, either politicians, business groups, interest groups, nonprofit organizations. And the idea is that if you have a high degree centrality, you know a lot of people, you have a lot of connections, so you can you obviously have a flow of information coming towards you. You can make connections with other people. You can try to persuade individuals to work in your favor. So for example, a politician that would have a very high degree centrality would be the Speaker of the House of Representatives, in this case, Nancy Pelosi, or the Majority Leader of the Senate, in this case, Chuck Schumer, or the President of the United States, Joe Biden, because they are connected to so many people, given their roles and responsibilities. Now, you might be asking, okay, well, what member of Congress would have a low degree centrality? And we could argue that newer members of Congress who are just got elected for the first time and they're starting their first 2-year term will have a lower degree centrality because they just don't know as many people as, say, someone like the Speaker of the House who has been in Congress for over or nearly 30 years. So this degree centrality is a way of looking at that. Now, when it comes to closest centrality, again, recall that this is close to many others indirectly. Now, if you look at this chart, you might be saying, okay, this is a little different than the one we were just looking at, because in the prior degree centrality chart, the countries of Eastern Australia, New Guinea, Western Australia, and others were tiny, right? Because that's based on the number of connections that you have directly. Well, closeness is about the number of connections you have indirectly. And if we look at the different countries here, we see Eastern Australia is its symbol is large. We also see Argentina seems to have a large symbol. Japan seems to have a large symbol. Madagascar seems to have a large symbol. Alaska, no. So these 4 seem to have large symbols. You might be asking, well, why do they have larger symbols compared to, say, the region of the Middle East, right? So, like, why is the Middle East smaller? And in this case, it's because Eastern Australia is it has more connections indirectly. So it only has 2 direct connections. So we'll call this, and let me lower the thickness of the pen a bit. I'll change the color here. So Eastern Australia has 1 direct connection and a second direct connection, right? But let's see how many indirect connections it has. 1, 2, 3, 4, 5, 6, 7, and go down the list, right? A lot of them. So Eastern Australia seems to have the most closeness centrality because it has the most indirect connections to all the other actors in this network. Now, the last one is the betweenness centrality. And again, this is the person or the object or the country or the region that serves as a key broker between many other nodes. So think about betweenness centrality as someone in between, right? Different groups, different things. So here we see, for example, that the Middle East has a high betweenness centrality. Brazil does, North Africa, Indonesia, Russia seems to be in the mix. Central America seems to be in the mix. And in this case, it's because the Middle East seems to be the largest because it not only connects a lot of Asia together, the Asian continent in the board game, but it also connects with another continent, in this case, Africa. And in this case, for Brazil, seems to be pretty large because it connects with all of the countries in the South American continent. And while North Africa connects with almost all of the countries in the African continent. And so this gives you a sense that it's not just about, are you in the middle, but how many do you bring between those 2 groups that you're connected to? And if you bring more groups together, then your betweenness centrality is higher. So in this case, the Middle East is bringing a lot of people together. It's bringing in it's bringing in 5 different countries, 8 different countries, 9 different countries, and it's connecting with another large one that's bringing in 5 or 6 connections. So you might be asking, okay, why does this matter in political science? Well, betweenness centrality is of interest to political scientists because we want to know who are like the gatekeepers. So instead of us calling them key brokers, we call them gatekeepers. Like, how do you get to influence somebody? And you might say, well, you can just call and email them, right? But let's just assume for a second that you don't have the President of the United States' cell phone, right, or email address. You're probably going to have to ask, like, who can I talk to? Like, do I know the chief of staff? Do I know the vice president? Do I know the senior advisors? Do I know someone who works in the White House? You might say, I don't know anybody who works in the White House, right? Then you would probably say, maybe my professor knows somebody. And I'd be like, maybe I do. I have to think about it. And if I don't, I certainly know somebody who does. And then we can kind of go from there. So I'm not like a gatekeeper, right, to your access to the White House. You can go to anybody, but I kind of serve as a gatekeeper because in your mind, you're thinking, okay, well, if he's a political scientist and he worked in politics, he probably knows people who are still working in politics. So I need to go through him as a key broker / gatekeeper in order to get access to the Congress or to the White House or to the like. So we in political science like to study that because those gatekeepers, those brokers have a lot of power. They have a lot of influence because if you're not friendly with them, if you don't share the same preferences as they do, if you don't have the same interests as they do, then they're not going to let you through, right, to that next step. So with that, I'd like to thank those who are able to attend live and to those who are watching the recording. Thanks, and we'll go ahead and get to our discussion. So take care.